on web here on WebEx. So I will start sharing my screen for you, so you can see my presentation. Do you see the presentation? Okay, very nice. So I want to start with a short introduction into me. So as you have seen in the event, the title for today is how to deploy a Java-Quarkus application on OpenShift. And I'm very grateful to be here today to give you a short introduction in these both technologies. So a short introduction to me. So my name, wait a second. So my name is Tim Schmidt. I'm 23 years old, and in my education I focused on developing Java applications for secure and distributed systems. And yeah, I'm a classic Linux admin. And with joining Viada, I grow up to a consultant for Red Hat OpenShift and grow to a DevOps engineer. So I want to say a few words about Viada. We are a classic consulting company, and we are Red Hat partners since 2006. So we can helping you with the Red Hat technology stack. We support software development and project realization if you need them, and give consulting and training for companies. But we can also support you with subscriptions and cloud and infrastructure. All of these are kind of things we have in our portfolio. So I will give you a short overview about this webinar. So in the beginning, I will give you a short introduction into Java-Quarkus, and I want to create a Quarkus project with you, our first Quarkus project, which we will later deploy on the OpenShift platform. And after that, if it's necessary, I give you a short introduction to OpenShift and show how you can start a local OpenShift on your desktop. And then, yeah, we switch to the main content. So I want to show you how you can deploy a Quarkus application on OpenShift with the OpenShift extension from Quarkus and with source to image. I think this both are the important. And yeah, if we have enough time, I will show you how you can deploy a Quarkus application from a Dockerfile and a container registry. And in the end, I give us a short evaluation, and then we have enough time for some questions and answers. But before I begin with this presentation, I have a link to you so we can interact with each other. So the website is Slido, and the hashtag is 44269. So we can interact with each other. So, and I have a first question to you. I'm very interested in from how classify do yourself, or classify the participants of you. Are you from a development? Are you from the operation, or from the DevOps or other? So I'm very interested in from where you are or how you classify yourself, that I can tell you better things about Quarkus and OpenShift. Oh, nice, 50-50 development and DevOps. No operations here. Yes, very nice. So we have a lot of dev guys here. I like that. So yes, very nice. I will before I start to give you an introduction to OpenShift, I start the next one. So I hope every has voted. So I want to know how many do you know about Java-Quarkus? Do you have heard before? Never have heard before? Do you have used it in some project? Okay, yeah, many guys heard it before. That is great. That is great. A few one says it's our daily business. It's great too. So yeah, I think that is not enough information for me. So I will give you a short introduction into what is Java-Quarkus. Okay, so in a few words, Quarkus is a full-stack Kubernetes-native Java framework made for Java virtual machines, and it provides a native compilation. I think that is why they named it Supersonic Subatomic Java, because this native application from Quarkus is very quick and very fast, but I will show you that later. Yeah, Quarkus is optimizing Java specifically for containers, so to become an effective platform for serverless, cloud, and Kubernetes environments. And it is designed to work with the most popular Java standards, frameworks, and libraries like Eclipse, IntelliJ, Spring, as well as Apache Kafka, Camel, Spring, and many, many more. The Quarkus dependency injection solution is based on CDI, so it context and dependency injection, and includes an extension framework. So you can expand the functionality if you need in your application. Adding an extension is as easy as adding a dependency, but you can use the Quarkus tooling, which I will show you later on. Yeah, it always provides the correct information to the GRAL VM. That is a universal virtual machine for running apps written in a number of languages, including Java and JavaScript. And with GRAL VM, we can run Quarkus natively. And yeah, in the end, Quarkus ensured that the further development of Thorn, Tail, or White by Form software project was discontinued. Yeah, that is the short introduction into Quarkus. So I have a picture for you, so I can show you how incredibly low is the memory footprint of a Quarkus application. It's up to 10 times lower than a traditional cloud native stack, and up to 7 times lower native as you run it with a JVM and via OpenJDK. So it has a very low memory footprint, and that is why it is so interesting. And yes, Java has Quarkus has a very amazingly fast boot time. So if you run a native Quarkus application, it could be up to 100 times faster than a Quarkus application with via the OpenJDK with just-in-time compilation, and maybe 4,000 times faster than a traditional cloud native stack. So this is why they name it supersonic subatomic Java. I think so. Yeah, so that's a short introduction. I will show you how easy it is to create the first Quarkus application for these guys which never do it. You can visit code.quarkus.io, and there you can click and collect your first Quarkus application. So I will name it quarkus.webinar and yeah, webinar-demo. So here you can find all the dependencies or all the extensions which are already prepared to run natively with Quarkus. So you have a lot of web dependencies, a lot of data dependencies for databases, a lot of dependencies or extensions for messaging, core, for a reactive application. And if you need some of them, you can click and collect them. I think for our first application, it's more than enough to use the REST easy JAX-RS extension. And then yeah, you can, with one click, you can generate your first Quarkus application. So later on, we need a Git repository. So I have created, for this session, I created one already. I will clone it fast for you. So my name on GitHub is Schmidt, and our framework, or our repository is Quarkus-webinar. Okay. Yeah, now we have to copy the folder for this time. So I will. Okay. Yes. Oh, we unzip is, I think that is self-explaining what I'm doing here. So, and in the webinar demo, you see you have the standard scaffolding for your first application. You have your Maven, your POM.xml, your README, and your first sources. So I'm copy them into our repository. Yeah, okay. And I will show you how easy it is to start developing with Quarkus. So I'm using IntelliJ for that. and I will show you how you can. I will open it in IntelliJ for you for the first time. Okay. Okay, for these who never started a Quarkus application, the most important file is a POM XML file. Here I will show you. They are all your dependencies, your information about your project, your group ID, your artifact ID, snapshot, and something like that. And your dependencies, you see, we have clicked the rest easy extension, and we have a lot more extension like JUnit. So yeah, in your source, we have an example resource. I will rename it for this webinar. So we can see it later on. And I would say, hello from Quarkus on OpenShift webinar. Okay. Yeah, we have a standard test with Quarkus, so I have to replace them in the test. And then we have created our first Quarkus application. Yeah, in the next step, I will show you how you can easily build your first application natively and non-natively. So you go back to your project, and with the simple command of .maven clean package, you can start your first JVM build. So in the background, he's building the first jar for our application, and it's creating the target folder where your final application is in. So yeah, we have 11 seconds. It was fast enough. So you can find the target folder now, and in the target folder you have the snapshot runner jar, and this contains our Quarkus application, and you can start it easily with java-jar slash runner. Yes. I'm sorry. Okay, yeah, now our Quarkus application is started. Remember, what you have to remember, you see, is a startup time. We have 0.7 seconds to start our Quarkus with the JVM, and now I will show you how fast a native build of Quarkus can start. So for building it natively, you need the GoRVM installed. I have done that before.
Excuse me, Tim, may I ask a question? So
yeah, sure.
Many thanks. So which JVM are you using currently when you started this Quarkus jar?
The Java version, you mean the Java version?
Mm-hmm.
I'm the 11.8. Yes. Mm-hmm. So it will work with the 1.8 Java, but it worked better with the 11th version of Java.
Thanks.
You're welcome. Okay. So and with Maven package -p native, you can trigger your first native build. So I'm in the wrong directory. So it takes this time because the native build of Quarkus needs a lot of memory. You will see it, but this little project will be built in maybe 1 minute, and then I can show you how fast it is to start a native build. Are there still other questions in this moment? Yeah, for the version, I've downloaded the Java 11 JVM and set them with alternatives Java, and you can download the Graal VM on GitHub, and I have put them just in the lib folder. Before I start this terminal, it is important that you export your Java home and the Graal home that it worked. So, but on the website from Quarkus is a very nice introduction to set up the Graal VM. I'm really recommended this. So you can see now we are using 3 gigs of RAM to compile it natively. So all of the memory, which will later be saved, or the resource saving running later from the native application, is that what you need to compile them one time. Oh, we don't need the site anymore. Okay, and the native build and the native runner of your application will also be in the target application folder. Okay, maybe in the chat, how often do you build a native compilation of your Quarkus? Do you need them often, or is it or do you use more the JVM version or the jar of Quarkus? Okay, yes, you can see the build time was 2 minutes, but if you switch to the target folder and run the native runner, you can see we have a startup time from 0.01 seconds. That is equal compared to 1.7 seconds with the jar. So it is incredibly fast, the boot time. Okay, yeah, that's our first step. We have our Quarkus application ready. Oh, we can check them by visiting the local host. And yeah, you can see hello from Quarkus OpenShift webinar. Very nice. So before I start with OpenShift, I'm interested in how often do you use OpenShift? Do you use Kubernetes or another platform? How do you deploy your applications, or how do you run your operation? Okay, a lot OpenShift, lot Kubernetes. No one uses other platforms for highly available operation. I like them. Okay, yeah, a lot of Kubernetes guys are here. So, but I think only 12 participants has voted. Okay. Yeah, it's okay. So I give you a very short introduction to OpenShift, okay? A very short introduction. So, okay. But in the time I will start my local OpenShift. So needs a few seconds. Okay, yeah, OpenShift. So what is OpenShift? Shortly said, OpenShift is a cloud-native development platform, you know them. And it's an open source platform which enables the developers to develop and deploy their applications on the cloud infrastructure. So summarized, this is a platform for high availability operation with and orchestration of containers like Kubernetes. Yeah, you have the same as Kubernetes. So you developer and operations can together deploy applications on this platform. You have, in best case, you have 3 master nodes, which will keeping the quorum, and they orchestrating the worker nodes like here displayed. So the worker nodes running on RHEL. I think Kubernetes it's Fedora or CentOS. And on these worker nodes, or that the worker nodes will provide the computing power for your applications. So you can install or deploy an OpenShift cluster or physical or on bare metal or on your virtual environment, but you can also deploy it on a private cloud if you have one, or on a public cloud like on IBM or other providers for deploying your high availability infrastructures. Yeah, you need a service layer. You need a persistent storage, I guess. And but OpenShift has this routing layer that is very nice to route the clients to your application and make it very easy to deploy some applications. Yeah, OpenShift has a self-service, has multi-language automation. You can collaborate with other people, and it provides modern security and modern standards. So summarize, it helps to shorten the time to deliver. But yeah, but at least I want to describe a little which is different between Kubernetes and OpenShift. So Kubernetes is like a framework or open source project. So it's like a kit that must be first assembled for guarantee a productive operation. Therefore, it needs an initial effort to be built. And on the other hand, yeah, with OpenShift, you have a code-ready product which is already assembled, and you can directly start with it. So you can start directly operating your applications on a high professional level. And in addition, OpenShift provides a big collection of instructions and best practices, so can be easy to use. And at least it is an enterprise product, so you will get support from Red Hat every time if you need them. So it's like a project versus product. So summarized, OpenShift is an operation-ready platform on enterprise level, which is powered by Kubernetes. Kubernetes is the engine of OpenShift. Yeah, but I think we skipped the demo. We will show, you will see the OpenShift platform in the next minutes. So then let's come to the main content. So deploying a Java-Quarkus application on OpenShift. So short instruction, Kubernetes and OpenShift provided containers, and Quarkus has a container-first philosophy, so we will deploy a container. In every time we take our application, produce a native executable or a jar if you don't need the native executable, and then you put your executable or your jar file and containerize it. So every time we use this kind of building. Yeah, but there are four different ways to deploy a Quarkus application. So Quarkus has an OpenShift extension. I will show you them in the first step, and you can deploy it with source to image. I will show you too, and if we have enough time left in the end, I will show you how you can deploy it from Dockerfile or from code-ready containers. Okay, but the extension. So how is the extension working? So instead of building from source code, the extension uploads the jar from your local file system. For that, and that is easy to configure because you only add the OpenShift extension, edit the application properties, and give there some configurations, and after that you can deploy the Quarkus application with one command from the local file system. The big advantage in this is it's easy and up to 10 times faster to deploy, so it is really recommended to use for development and testing. But as a disadvantage, it is only good to use while developing locally and non-productive. The more recommended way is to using the source to image option. So you build a container for the source code on OpenShift. For that, in your Quarkus application, you have to create a source to image folder and add some files, some configuration files, but it's not many work. And yeah, you need a Git repository because after you push your source code into the Git repository, you select on OpenShift, you select the builder image and deploy application from the source code. And the advantage is this method is recommended to use and it is widely used for production. And the next big advantage is for build and compile, you can use the computing power from the OpenShift cluster. So you have nothing to build locally, so not the application and not the container. But it takes long build times, so it is not recommended for development and testing. Yeah, the third one is using the Dockerfile. So you can build build the container on OpenShift, on the OpenShift cluster from the Dockerfile. For that, you need a Git repository, but you have to build and compile your application locally and push them into the Git repository. And after you do that on OpenShift, you select the Git repository and the Dockerfile, and you can deploy it easily from the Git repository because the standard Docker files are already contained in the standard Quarkus project. But I will show you later. Yeah, and I think that is one of the easiest ways to deploy a Quarkus application on OpenShift. But as a disadvantage, the application must pre-compiled locally, also the native build. And if you have big applications, maybe you have not enough RAM on your desktop PC. And yeah, the container. Oh no, the container must be pre-built. You can pre-build the build will be run on the OpenShift cluster, but not the container. The application must be pre-built and must replace in the registry. And I think ready applications in a Git repository is not state of the art. Yeah, using the code-ready container is the fourth option to deploy an Quarkus application on OpenShift, so you can easily deploy a code-ready container to OpenShift. So you have to add the Quarkus extension. That is very easy. Then you have to build and compile your application locally, build the container locally, push the container to any image registry, and in the end, you can deploy the container on OpenShift from the image registry. I think that is a very easy deployment too, but as a disadvantage, the application must be pre-compiled locally, and the container must be pre-built and must replace in the Git registry. So you have a little bit work on your local PC. Yeah, but yeah, that is the theory part. No, I would say let's deploy some applications, some Quarkus applications. So first of all, we need to log into OpenShift into our OpenShift cluster, which is running locally. So if you don't have set the path, you have to export your origin client. If you're using the CRC, so the code-ready containers on your local desktop, you can use it by using this command. And after that, you can log in with developer. That is a predefined account. So user is developer, password is developer, and the RP address or the RP domain is rp.crc.testing on the standard port 6443. Okay, so with the command lc --- show console, you get the console domain for your OpenShift cluster, so you can easily come in. Okay, and now we have our local OpenShift cluster. Yeah, I would say we start with the OpenShift extension. So it is very easy to add to your Quarkus application. Well, for that you need one command with the .maven w and Quarkus add -extension and the extension is OpenShift. So you add the extension to your POM XML. So after you execute this command, you can look in your POM XML and you will see in your dependencies, where is it here? Dependency, you add the Quarkus OpenShift extension. So after adding them, we have to edit our application properties. You will find it under the resource ordner. And there we have to add three important things for this scenario, because so the OpenShift cluster the local OpenShift I used has a self-signed certificate, so you have to trust them. You have to select your base image or your builder image for deploying it on OpenShift. For that I will use the registry access Red Hat OpenGDK 11. 11. So we will deploy the jar with this extension, and you have to expose a root so that we can reach them later on. Okay, yes, this was 2 preparations for deploying it, and I will copy paste them to save time. And with one command .maven w package -d Quarkus Kubernetes deployment is true, you can start the deploying on your OpenShift. So it maybe takes us time, 1 or 2 minutes. So We have just to wait. I think the project will appear in a few seconds. Oh, well. Did I forgot something? It doesn't work, a build fail exception. Developer doesn't have permission. Okay. So I swear that it has worked 2 hours ago. Third exception. Did anyone see the fail? What I've done wrong? Or did I forgot something? Ah, yes, we forget to do a new project. I'm so sorry. So we have to create a new project. So a new project on our OpenShift platform. I will name it qdemo extension JVM. I forgot them. I'm so sorry. Yeah, and now you can deploy your application in this project. Oh well, I forgot this command. I'm so sorry. Yeah, and you can see here is this your first project, the extension, the qdemo extension JVM. And it will take it will take this time, I would say, to save time. I will start to show you how you can deploy it with source to image and do the preparations for that. So I will start a new terminal. So for using source to image, I said we have to create a source to image folder for our configurations. And in this source to image ordner, we have to create an environment, a file named environment. And there we need only one line of code, and it is where he can later on find the runner jar. So yeah, no more preparations for using source to image for JVM. So now, but we need this in our Git repository. So I will commit and push these changes. Okay, what does our extension deployment, how does it work? Okay, I think we have, we are in the wrong project. Okay, yeah, okay, you can see our extension has created the base image we're using, the OpenJDK 11 rel base image, and our webinar demo. The build is still running. We can take a look. Okay, so he is in step 10. Yeah, he built the container. I think maybe a few seconds more. Okay, it's complete. Very nice. So we can just take a look. Our deploy has run. Okay, and our container is running. And you can see you have started the Quarkus application on your OpenShift. So, but it needs 3 seconds to start up. So it's a long time for a JVM. And if you want to look if it really runs, you can go to your roots and visit the application. And I think we're hello. Yeah, we find the hello from Java-Quarkus. Very nice. It works. So now we can deploy the source to image because we have pushed our all what we need in our Git repository, but we forgot the target folder. I'm so sorry. We have to, yeah.
Quick question for chat. Do you have the Git tutorial to share with the audience to follow along?
The Git the what the
tutorial?
Ooh, no, I don't have this tutorial.
Okay, no worries.
I'm so sorry. But I can in the end I can give you some links for that. The most so I can wait, I will yeah, here I have the link. I will share it with you. So that is the official Red Hat instruction how to use the extension with the commands. And they can show there are also the source to image instructions. And the other I will give you is all from Quarkus.io. So yeah, we need the target folder later. Okay, so we can just use the developer view to deploy from source to image. So we have to create a new project. I will name it qdemo/source to image JVM. I think it's self-explaining why I name it like this. Yeah, and it's very easy. So you can just use the Git option for deploying a new application. You have to give the Git repository, which we already have, and you have to click. You select your builder image. I use the 11th version of Java, and yeah, after that, for scale them up, we need a deployment config, and then we just click create. So a few steps: Git repo, builder image, name, deployment config, and create. And now he's creating our first source to image deployment. So he just do the same as in the extension. He's cloning the Git repository. You can see the last commit, the hotfix I have done. And now he's building the container. That will take a few minutes. So I will use this time to show you how you can deploy it natively, because you can deploy your application with source to image, and the OpenShift cluster will native compile your application. But for that, we have to go to use another builder image. So I will do that from the command line, if it is okay for you. So we have to, so I want to create a new project for this, new dash project, and I name it qdemo dash source to image dash native. Okay. That's the wrong. We have to go here. Ha. So no, it was wrong. Okay, and you can see already, here is it, the native project which we create from the command line. Yeah, for that, so I can share you the link for that. That is the official Quarkus instruction to deploy this. The native version of your Quarkus application with source to image. So what we have to do is using another building image. So we have to import them with the OC command. Okay. So we need Quarkus provides for that a Quarkus. No, that's not. It's the wrong. Okay. 1 second. But if you can in the you can see we need to import. So also import image -- confirm. I will name it, yeah, ub-quarkus native, and it comes from the Quoy, QQ registry, CRY-O. Why this command failed? Import image. Confirm. Does anyone see why this command failed? Invalid argument. Ah, my fault. My fault. After confirm, there is no equals. I'm so sorry. So okay, the import was successful. So if you see, you can check it with on your image stream. So now we have the UBI Quarkus native builder image we need for the build. And yeah, after building this, you can just start building your app with saying, okay, you want this native base image, what we have here, your Git repository, what is Schmidt Quarkus -webinar, and in which namespace you will deploy it with qdemo source to image -native. So, and then very fast, a new build config will be created. Quarkus, oh, I have named it. I have forgot the E by importing this this builder image. So, but yeah, Miriam, can I share a local PDF document with the chat? Can I upload a local PDF document? Okay, very nice.
If not, do you want to share it right now or after the session?
I can share it now or after the session. There are a lot of commands I used.
Okay.
Okay. So one important thing, your build has only 1 GB of RAM by default from the OpenShift cluster, but a native compilation or a native build needs much more memory. So you have to configure the build config and editing the resources. That is one of the important steps, because if you don't do these kind of configuration, your build will be fail. So you can do it by hand in the YAML config, or you can just use a command for that. I like to use this command because it's a little bit easier, I think. And you can do this with OC patch. Yes, OC patch build config from qdemo source to native. That is the name of the namespace of our application. And then under spec resources, we set the limits for CPU and memory. And you have to increase the memory that you can build them on the OpenShift cluster. Now you can see, if I reload them, you see, okay, here in the limits, resource limits, you have more memory for building it. So after this, so this will fail, so we can delete this build. After that, you can rerun it with start build. You can do it from the command line too. So if you like command lines or the user interface, it's your thing. What do you want to use? But in my case, it's still pending and it will never leave the state, because my local OpenShift cluster has not enough mini shift on my PC, on my desktop, has not enough resources to compile them. So it will never leave this state pending. In my case, if you have a big OpenShift cluster with more resources, it will be work. Okay, yeah, these are the both source to image, the important source to image deployments. Are there questions so far, or some important questions?
Just one question from my side. When you
Yes.
look at WebEx at the top, does it say, is it in English or in German?
Mir egal.
But on the file edit and then the share content, if you have those rights as presenter, maybe.
No, I don't think I have this rights to do that.
I think we'll share the PDF afterwards.
Okay, yeah. So in the PDF, I have collect a lot of this commands. I will share it in the end. Okay. Okay. So it's 10 minutes before 2. So if you want, I can in the last step I can show you how to deploy from the Dockerfile. It would be very fast, or we can start the question and answer session if you want. So let the participant decide what we do next. I think so. Do you want that I show you the last step from the Dockerfile, or do you want to do your questions? Okay, Simon want to see from Dockerfile? Okay, very nice. So that is, I think it's one of the easiest ways to deploy it, because the Dockerfile is already contained in the standard Quarkus project. So you can see here at the Docker folder, you have a Dockerfile for JVM and the Dockerfile from native. So you don't have to touch any of them. You don't have to create an own Dockerfile. You can just deploy this. But you have to pre-build the application, JVM or native, what you're using, and have to push them into the Git repository. I already done this, I hope. So here's the target folder. So now the deployment is very, very easy. From a developer view, we just create a new project. I will name it qdemo file native. We first deploy the native one. So, and after you create this, you just put the from Dockerfile option, and now just give the Git repo, the Quarkus GmbH, and the source, the path to the Dockerfile. And that is source main Docker native. I've shown it in the IntelliJ, it is already there. And after doing that, give the Git repository, give the Dockerfile path. I will want the deployment config. You just click on create, and they will build the container from the Git repository for you. So this is building right now. I will use this time to deploy the non-native version, the jar, so I can show you the big difference in the boot time. So I name it JVM, and then we just take the other Dockerfile. So we are here using the Dockerfile option, select our Git repository, go to the Dockerfile, in this case docker.jvm, click on deployment config and create them. And
excuse me, Tim,
yes.
may I? Sorry, when you choose the option with the JVM, so
yes.
this would, to my understanding, you need Docker parent, which also already includes the JVM, or how?
Yes. Here you can see, when you look at in the Docker files, you can see the base image for okay, no, we just take the normal universal base image from Red Hat, and for the native we will use them too. So we have the same base images.
Ah, okay. So the base image already includes the JVM.
Yes.
Okay, cool.
Also for the non-native, So the Red Hat has this UBI, so the universal base image. All JVMs, all jars, or all the Growl VM, all is included.
Okay, fine.
So you can use your own base image if you want, but in my case, I don't touch them.
All right, thanks.
You're welcome. So yeah, just take a look. Native build. I think for the native, I think That's extension. Oh, I name it extension native, or where I deployed here file native. So the pod is running, and we can view in the logs, and you can see how incredible fast they boot. So 1.103 seconds is nearly nothing, and you can in this view, you can easily scale them fast up. So if you need Quarkus on demand, it can scale up very fast. So you can just scale up the pods, and it will very, very fast to scale them up. Yeah, so image JVM, I have named it image JVM. So that is not ready yet. Okay, but yes, so I think we have only 5 minutes left. The container ready, how to deploy a container ready version, I don't think we have enough time for that. So in the end, we will take a look how fast the non-native version of Quarkus needs to start up. But the build still running 3 minutes ago. But I think okay, can't open file. Okay, I think there went something wrong, but I let them run. So okay, I switched to the evaluation. So 1 second. Okay, in the end, Quarkus is created for microservices. So Quarkus performs very well as a microservice because you has the unbeatable memory footprint, and it has an amazingly fast boot time. So if you need them on demand, it would be the right framework for you. So Quarkus is on-demand, fast, scalable, and resource-saving Java. That are the big advantages using Quarkus. The disadvantages are, yes, you have long native build times. If you have a big application, you need a lot of memory to compile it natively. So you have a high resource consumption doing the native build. And one disadvantage is not all dependency from the classic Java EE are ready for the native build of Quarkus. Maybe in a few months, in a few years, we will see. But yeah, I would say Quarkus is not made to replacing a classic enterprise application platform. So in the end, I would say Quarkus does not replace classic Java. There are a lot of scenarios where you need a standard Java EE application server, but it complements the Java toolbox. Yeah, and then I would say thank you for listening, or yeah, contact us if you have any questions. So here's a mail. You will reach us, and in the end, thank you for listening. And now we have, I think, a few minutes left for question and answers.
Thank you so much, Tim. We've got one question in the chat from Simeon. Okay, the commands from the builds PDF.
Yes. I have an idea. I will push them in the Git repository too, the PDF document, so you can pull them. I do not delete this repository, so you can use them if you want. And yeah, I push the PDF after this session. I will push the PDF in there, and maybe a file with all the links I have used. Okay.
And I'll post a summary of all the links from the chat into our different meetup groups, so everybody has a copy of them.
Okay, yes, very nice. So are there questions left? Do you want to learn more about something? Maybe are interested if we do a second or third webinar. What do you want? Which kind of webinar do you want? Do you want more OpenShift? Do you want more Java-Quarkus? What do you want? Testing, more testing? Nice answer.
I'm also curious, this is our first lunch and learn session at this time slot. So if this was a good time for you, or it's more difficult than going to an evening session, that's also interesting.
Okay, more OpenShift. I see more OpenShift. I prefer the German morning time. Yeah. Yeah, I think testing is one of the important module of developing software.
I'm going to stop the recording.
Okay, very nice.